So hello future achievers, one of the most simple topic and one of the most kind of confused topic. Today we are going to understand molarity, okay, the definition, okay, the simple questions, okay, and what happens to molarity when there is a dilution, what happens to molarity when there is a mixture, okay, and all of these type of questions we are going to understand in this particular session only, okay. So I hope everybody is like familiar with the definition of molarity, okay. Can you tell me what is molarity? So the definition of the molarity is, it tells us how much number of moles is there in a unit volume, okay. Now I hope you know what is solute, what is solvent, okay. Tell me what is solute. What is solute? Obviously solute is the like hard particle, okay, and it is smaller in quantity. It is smaller in quantity, okay, and solvent is okay. Okay, solvent is not mentioned here. So remember, when you add solute with the, let me change the color, okay, when you add solute with the solvent, okay, you get a mixture, okay, and that mixture is known as solution, okay. I hope you know this, it's very basic, right? So solute, for an example, maybe like NaCl, okay, a normal table salt, our normal salt that we use in veggies, okay, and solvent may be like water, okay. When you mix both of them, what you get? Solution, okay. Remember, there is no chemical reaction that is happening between both of them, okay. This is not our topic of discussion. Our topic of discussion is molarity. So what is molarity? How many number of moles of this solute are there in this particular solution, okay. So solution consists both of solute and solvent, okay, solute and solvent, comparison to what? The solute. So it means it is just telling us about the concentration of solute over solution, okay, and you can write solution as solute plus solvent, okay, right. So it tells us about the number of moles of solute per unit volume of solution in liters. Remember, when we are talking about solution, we are talking about volumes of solution, okay, and moles of solute, okay. So like 1 mole per unit volume, okay, 1 mole per liter, 1 mole per milliliter, right. This is how we represent molarity. I hope the definition is pretty clear, okay. Let's go on to the next slide. Okay, listen, most of the time in questions they are not going to, sometimes they are going to use very tough words, okay, unfamiliar words, not I'll not say tough words, but I will say unfamiliar words, like see, okay, see, they might be using, see, when they say 1 molar solution of a substance, okay, 1 molar solution of salt, 1 molar solution of K2CO3, 1 molar solution of HCl, it means they are telling you what? They are telling you there is only 1 mole of the solute in 1 liter of the solution, okay. Same way they can say different ways also. For an example, when they are trying to represent 0.5 molar solution, 0.5 molar solution, can you tell me? Explain what is 0.5 molar solution? 0.5 moles per liter, that is called 0.5 mole solution, okay, and that is known as semi-molar. Got it? You can say, like in the question they can say semi-molar solution of this salt, then it means 0.5 moles per liter of the solution, okay. I hope you understand. So when they say decimolar, it means 0.1 molar, okay. Decimolar means 0.1 molar, centimolar means 0.01 molar, okay. Bimolar means 2 molar, okay. Remember, 2 molar, bimolar, 2 molar, okay. So whenever they are saying semi-molar solution, it means 0.5, okay. So you need to understand, when they say semi-molar, it is 0.5, when they say decimolar, it is 0.1, when they say centimolar, it is 0.01, when they say bimolar, it is 2 molar. I hope you are able to understand this, okay. Now we are clear with the definition, right. We are clear with some of the numeric like names they use, okay, some unfamiliar name they use. Let's go through one question. I think next slide is the question one, okay. I will not do this question, okay. Let's see if you are able to do this question. Pause the video, okay, and try to attempt this question, and I hope you have paused the video and try to do this question. Let's understand, okay. How can we do this question? So the question says, calculate the molarity of a solution. We have to calculate the molarity of a solution. Can you tell me what is molarity? Number of moles per unit volume. Okay. Molarity of a solution containing this much gram of NaCl in 500 milliliter of solution. Okay. So what is molarity? What is molarity? It is number of moles, okay, of solute per unit volume of solution. Okay, right? I hope you understand. Now it means N by V, V of the solution, okay, and N of the solute. Got it? So how many number of moles of solute is there in this question? So 5.85 gram of NaCl. So what is, like, how can you find number of moles if the molar mass of the NaCl is 58.5? okay, so how can you find moles? Given volume, okay, upon molar given mass upon molar mass, that is how you find moles and volume. Now what is given mass? 5.85, and what is the molar mass? 58.5, right, divided by the volume. So volume is 500 ml. Should I write 500 over here? Should I write 500? No, I should not write 500. I have to write it in terms of liters. So 500 milliliters is equal to 0.5 liter. Okay, so it means 0.5 liters. I hope you are able to understand, right? We have to get the answer in the correct units. Okay, so 5.85, 58.5, I think it will cancel out with 1 by 10, right? So now this 10 will get multiplied over here. So 1 by 10, and that 0.5 we can write it as 1 by 2. So 2 to cancel by 1 by 5, and 1 by 5 is what? 0.2. Okay, so it means 0.2 moles per unit volume of the solution. I hope you are able to understand this solution. Okay, it was a simple question, simple. Number of moles we find out, we divided by the volume of the solution. Okay, and volume of the solution we write it in terms of liter. Remember, the units are moles per liter. What are the units? Moles per liter. Okay, let's go on to next slide. Now see, there is a concept of dilution. Okay, we have some kind of solution. Suppose in a bucket we have this solution, okay, and this bucket, okay, the solution in this bucket is having a molarity of M1 and the volume of V1, okay, but what I did, we added some water into it. Okay, what you call it, some water or whatever the solvent is. Suppose the solvent of this thing is water, so I added more water. So what will happen? The volume of the solution will increase, right? Okay, so volume of the solution increases, so it means the molarity will change. Yes or no? Obviously the molarity will change, and also the volume has increased, so volume will also change, right? Now how can I find M2? See, M1 will be given, V1 will be given, V2. I want a relationship between them. Tell me one simple thing which is not changing in both of them, M1, V1, M2, V2. Which one of them is not changing? What thing is that which is not changing in both of the cases? And that is number of solute. Okay, number of moles of solute, sorry, not solute, number of moles of solute. See, the solute particles present in it and the solute particles present in this one, are these solute particles equal? Yes or no? Yes, obviously they are equal. If solute particles are equal, it means, so it means, sir, M1 is equal to N by V1, okay, and here M2 is equal to N by V2, right? It means N is equal to M1 by M1 into V1. Here N is also equal to M2 by V2, right? Now you can see here N is equal to this, N is equal to this. It means both of them should be equal. So it means M1 V1 is equal to M2 V2, it means this is the formula that we get. So remember, during the concept of dilution, the number of moles of solute, they do not change, okay, and to find out the relation is m1v1 equal to m2v2. Initial molarity into initial volume is equal to final molarity into final volume, right? I hope you are able to understand this. Number of moles of solute remains constant, okay, and the volume increases and the molarity decreases. When you increase the volume, okay, so moles per unit volume, they will decrease, got it, because the volume has increased, okay, so the molarity will decrease. So because the volume has increased, remember, so the molarity will decrease. Note it down in your notes, okay. I hope you are able to understand this. Should we do one question? Okay, here we have one problem on the molarity after dilution, okay. So we have to find the molarity after we are diluting the solution, okay. Now see, 200 milliliter of 0.5 HCl solution is diluted to 500 milliliter. What is the final molarity, okay. So it means there was a bucket, so there was 200 milliliter of what, 0.5 molar solution. 0.5 molar HCl solution is diluted to 500, okay, this is 200 milliliter, okay. Now you are adding water in it, so it means you are diluting the solution. So when you are diluting the solution, what is happening? The volume is going to increase, right? So this is how much? Now earlier there was 200 milliliter, right? And now there are more 500 milliliter water, okay. So extra 500 milliliter, and earlier it was 200 milliliter. So what is the total volume? Now the total volume is what? 700 milliliter. And what is the molarity? No, we do not know the final molarity, right? So we have initial molarity, initial volume. Final molarity, I have to find final volume, we know. So what is the formula that we studied? m1v1 is equal to m2v2, right? Now m1v1 equal to m2v2, what is m1? 0.5. What is v1? 200 milliliter. Sir, why are you not writing 200 milliliter in terms of liter? Listen, even if I write it in terms of liter or in terms of milliliter, it doesn't matter. Suppose, why? I'll tell you. See, if I'm writing this in milliliter, I will also write this in milliliter. So this unit is going to cancel out, right? So it doesn't matter whether you write this in liter or milliliters, because it's a ratio, right? At the end, it's forming a ratio. So it doesn't matter whether you are writing this in milliliter or liters, okay. Now you cancel these 2 zeros with 2 zeros, okay. Anything else is left? So m2 is equal to 0.5 into 2, that is 1 by 7. So m2 is equal to what? 1 by 7. I hope you are able to understand the situation, okay. What we did? 200 milliliter solution, extra added 500 milliliter. So molarity changes, volume increases, so the molarity should decrease, okay. And obviously this 0.5 is greater than this one, okay. So our answer is right, got it? That's how we found out, we can find out the molarity after dilution, right? Okay, next concept. Next concept is molarity of mixture. How can we find out molarity when we are mixing, mixing two solutions? So m1v1, m2v2, they are mixed together. Now when they are mixed together, what is the molarity of the total mixture? How can we find this out? Okay, sir, let's just understand, okay. How can you find this out? See, try to run, utilize your mind, okay. Try to answer before me. See, there is one container, in the container, okay, m1 v1, okay. Another container, another solution, m2 v2, got it, okay. Now we are adding this together in one single container. So what will be the volume? Sir, volume here is v1, volume here is v2, so it means sir volume will get added, okay. I hope now you are able to understand this, right? So suppose in this solution there are n1 number of moles, right? And in this solution there are n2 number of moles. Okay, just think about this. So it means in the last solution, what will be the total number of moles? N1 plus N2. Okay, sir, what will happen if there is a chemical reaction going on? Remember, if the chemical reaction is going on, then you have to find out the number of moles of products. Okay, but in that case, that question, they will not give you that question. Okay, remember, so N1 plus N2 if there is no chemical reaction. Okay, when solutions are mixed, the total moles of solute are divided by the total volume of the mixture. Okay, now we have total number of moles, we have total number of volume. So can you tell me what is the formula for this mixture? For the molarity of the mixture, okay, what is the formula? Number of moles, total number of moles upon total volume. But sir, we are not given with total number of moles, we are given with the molarity. Then you can write N1 is equal to M1V1 and N2 equal to M2V2, right? Now put this in here, you will get your formula M1V1 plus M2V2, okay, and V1 plus V2. This is the same formula, right? Are you able to understand how we got this formula? Number of solutes are getting added, volume is getting added, okay, and the molarity is changing. I hope you are able to understand this. Should we do one question? If you are not able to understand, just revise this particular section of the video, okay, and then you will understand this. And make sure to note this down in your notes, okay. Okay, so last question of the day. Okay, we will finish our lecture with this last question. Before I try to attempt this question, try to attempt it by yourself. Pause the video. I hope you have attempted the question by pausing the video, and some students, they never pause the video. Okay, now 500 milliliter of 1 mm HCl, okay, is mixed with 300 milliliter of 0.5 MSCl. Find the molarity of the resulting mixture, okay. And remember, these are the same solutions, okay. It doesn't mean you are mixing HCl with NaOH. Don't do this. Why? Because they will be reacting with each other. If they are reacting to each other, different amount of moles will be there, because now they have reacted, okay. So instead of HCl, NaOH being present in the solution, you will find NaCl and water present in the solution, because neutralization reaction will take place. I hope you are able to understand this, right? There should be no chemical reaction when you are mixing the solutions, okay. Now 500 milliliter 1 MSCl. What was the mixture formula? Tell me, what is the mixture formula? Sir, mixture formula is M1V1 M2V2 V upon V1 plus V2. Okay, what is M1? Sir, 1M. And what is V1? Sir, 500 milliliter. Should I write this in liter? It doesn't matter you write this formula in liters or milliliters, because see, V1, V2, okay. I hope you have heard about dimensional analysis. So the volume will cancel out, okay. The dimension of the volume will cancel out. So either you write everything in milliliters or either you write everything in liters, okay. That is important. I am writing it in milliliters, that is the way it is given, okay. And 300 milliliter 0.5. So 0.5 and 300. M1V1, M2V2, simple, right? 5, 6, 7, 8. So these two zeros cancel out, okay. And 0.5 into 3 is 1.5, and 5 into 1 is 5, divide by 8. So what is the answer? 6.5 by 80, like 8, okay. So it's like 65 by 80, okay. It doesn't matter, you can just like divide the answer and get the answer, okay. That's how it is done. I hope you are able to understand this particular question, okay. So what is molarity? Number of moles per unit volume. What happens in dilution? Sir, the volume increases and the molarity decreases. What happens in mixture? Number of solute, okay, number of moles of the solute, they get added, the volume also get added, okay. Now make sure to remember the formula for dilution, remember the formula for mixture, okay. Till then, bye bye, see you, have a nice day and keep studying.